In this experiment, we are going to investigate the migration of the auxin under different direction of illumination. But before I talk about the experiment, actually I would like to recall or highlight the first paragraph of the experiment. It say that the coleoptile, which is frequently used as the convenient plant material for the experiment on phototropism. I just want you to recall the reason why the coleoptiles are used in the tropism experiment, but not a mature plant. Okay, we use the young seedlings, okay, for the tropism experiment. So you can recall the reason in the textbook or in the worksheet. Okay, so we enter the experiment and talk about it that the tip, okay, were removed and placed on the agar block. And for the agar block, there are the thin sheet of the metal to separate the agar block A and B or C and D. But beware of that. Actually, the metal sheet, okay, is not insert, okay, completely, okay, to the tip, but just halfway, okay, or less than halfway. Okay, so you need to think about that, whether the auxin they can migrate, okay, within the tip, okay, within the tip if they need to move, okay, from one way to one way, okay, to the other way. Okay, so can they move? You need to think about it. And after that, okay, there are two cases. Okay, the first cases is that, okay, we shine the light, okay, evenly to the tip, okay, and let's see where how can the auxin move. And it is the uniform illumination, illuminated evenly from above. And the other case is that there is a unilateral illumination from the right hand side to the tip. Okay, so that's why I want you to think about the migration of the auxins under the different direction of illumination. And also, okay, why do we insert, okay, the metal sheet? Okay, because I will also want you to think about the permeability of the agar block and the thin metal sheet. So that means whether the auxin they can diffuse, okay, to the agar block or diffuse across the metal sheet. Okay, of course you should know that the metal, okay, it is impermeable to the auxin. So that means the auxin cannot pass through the metal. But as I said before, the metal, it is not insert completely to the tip, okay, just halfway. So that means can the auxin move from this side to this side? Okay, you tell me. So for the question, okay, because, okay, the coleoptile are decapitated, so that's why we need to put back the agar block A, B, C, D back, okay, to the lower part. Okay, so in ensures that the auxin source comes from the agar block, okay, because the tip, okay, will not be put back, okay, to the coleoptile. Okay, and for the experiment, okay, for this part, okay, I would like to mention is that actually for the first part, okay, we need the light. But for the second part, okay, when we put back the agar block A, B, C, D to the coleoptile, okay, this part, okay, should be done in darkness, okay, because we do not want uneven distribution of auxin after this part. Okay, there may be an uneven distribution, but for this part, what I care is just growth or not. Okay, I don't care whether the coleoptile bend to the right or bend to the left. Okay, I don't care. I just want to see whether they can grow. Okay, so some factors I would like to highlight is that based on the growth rate of the decapitated coleoptile, we can estimate the relative concentration of the auxin in agar block A and B, also C and D. Okay, so for example, for agar block A and B, they need to the same growth rate, okay, right? After 2 days, okay, the coleoptile, both of the coleoptile be below agar block A, below agar block B, okay, they grow up in the same degree. Okay, so we if we need to compare the relative concentration of the auxin, so we can say that actually algal block A, algal block B, they contain the same concentration of the auxin to stimulate or to promote the same degree of growth, right? And for algal block A, B, C, how about D? Because D will be asked in the question, so I exclude it. Okay, I just compare A, B, C. So actually they need to different growth rate, especially for the coleopole below the algal block C. Actually it grows up, and the degree, okay, of growth, okay, the growth rate is a little bit higher than that of the coleopole below the algal block A and B. So that means the coleopole, okay, in this setup, okay, actually it is promoted. The growth rate is promoted, okay, than the normal case. So if we need to compare the relative concentration of the auxin, somehow we should know that the algal block C, it contains higher concentration of auxin. So that means in this case, I want you to really think about it, the uneven distribution of the auxin under the unilateral illumination. Okay, and for the questions, okay, for part A, we need to draw the diagram of the algal block D. Okay, so remember to show the comparison for me, but not only draw this part, okay, because you need to complete the diagram. Okay, so actually you need to recall the effect of the unilateral light on the distribution of the auxin. So which block, okay, which algal block C or D will contain higher concentration of auxin, and that particular concentration of auxin will promote or inhibit, okay, or stimulate or inhibit the growth of the coleopole below the algal block D. Okay, so that's the part A. And for part B, you need to explain the changes in height of the 4 coleopole. So the case is that because in this question, okay, it doesn't tell you the change in height. Okay, so that's why you need to compare the changes in height first, okay, and then explain the answer for me. Okay, so I break down these 4 marks in 2 parts, 1 and 2 and 3 and 4. So for the first 2 parts, it's talking about the coleopole below the algal block A and B. So what you need to do is compare the changes in height of the coleopole below algal block A and B, okay, these 2 coleopoles, okay, and then explain why, okay, the changes in height, okay, is the same, okay, because the growth rate, okay, they are the same actually. So you need to explain why, okay, the growth rate is the same according to the distribution of auxin. And of course the hint is that the distribution of the auxin is due to the illumination. For A and B, remember that it is the uniform illumination, right? Okay, and for part 2, 3 and 4, okay, that means you need to compare the changes in height of the coleopole below the algal block C and D. Okay, C is given, but D, okay, it depends on the part A, okay, your answer. So you need to compare the changes of the height, okay, which one may be taller or which one may be shorter, okay, and according to these changes in height, okay, or taller or shorter, okay, so you can estimate the distribution of the auxin in the algal block C and D and explain why, okay, either one of the algal block C or D, okay, which one of them will contain higher concentration of the auxin, okay, and of course the hint is about the unilateral illumination, okay, for this setup, okay. And for part C, okay, we need to explain the reason for the inclusion of the blocks A and B in the experiment, okay. So for the setup A and B, why do we need to set up these 2 parts, okay, but not just set up algal block C and D, okay. So for A and B, we know that by the uniform illumination, okay, actually for the algal block A and B, okay, it will result the same concentration of the oxygen, because it will not, okay, need to the uneven distribution of oxygen. Okay, so that means for the block AB, okay, they act as a which type of experiment in order to confirm that, okay, which type of illumination will affect or will lead to the movement, the migration of the oxygen. Okay, so that's part C. So for the question 21, actually it is a DSE question. And the main theme of this question is about the nature of science. But apart from this part, okay, we also need to apply the knowledge, okay, of analyzing the data, analyzing the result of the experiment. Okay, so for this part, we have the Darwin, okay, the Darwin experiment on phototropism. So also in the dark box, and one hole is cut, okay, for creating the unilateral light, right? Okay, and also for some word, okay, intact, that means the complete coleopod, that means with the tip, okay, and for the opercle, that means non-transparent, okay, that means even the light is shining on the tip, okay, but this opercle cap, okay, just block the stimulation from the light. Okay, so I want you to record the conclusion draw in this experiment. Okay, for the result of 1, 3, and 4. Okay, actually it will be asked in the question. So I just highlight the result of the coleophods 1 and 2. That means setup 1 and setup 2. Okay, that's a typical comparison. Is that okay for the setup 1? Okay, with the tip. Okay, and with setup 2 without the tip. Okay, so you can see that with the tip, growth with bending, without the tip, no growth and no bending. So we can say that the tip is necessary for growth. Okay, that's the first conclusion draw in this experiment. But how about 1, 3, 4? Okay, that will be another conclusion being drawn. Okay, so for setup 3, setup 4, okay, either the tip or the body, the lower part of the coleopod will be covered. Okay, and for the questions, okay, question A, okay, from the result of the experiment, okay, which part of the coleopod is responsible for detecting unilateral light? Okay, support your answer with reason. So remember that, okay, you need to recall the result, okay, but not just tell me the answer. Okay, remember 3 marks, and the mark allocation will be the conclusion 1 mark, and for the experimental result, okay, for the other 2 marks. Okay, so as a topic sentence, you can tell me the tip or the lower part, or which part is correct. Choose one part. Okay, the tip or the lower part of the coleopod is responsible for detecting the unilateral light. Okay, that's the topic sentence, and for the explanation, record the result of setup 2 and 3. Okay, also you need to pick up the correct choice. Okay, if the tip or if the lower part of the coleopod is removed or blocked from the stimulus. Okay, so you can refer to the setups 2 and 3, whether the tip or the lower part of the coleopod is removed or blocked from the stimulus. Okay, and then any growth or bending will be observed in these 2 setups. Okay, so you need to complete the sentence for me. And then on the other hand, okay, we record the result of the setup 4. Okay, so according to setup 4, which part of the coleopod is covered in soil, okay, or is covered by the pot or something like this. Okay, so what will be the result, growth of or bending, any observation? And for part B, okay, the question is asking why it is necessary to have setup 3 in the experiment. So you can refer to the diagram. Setup 3 is about we use the intact coleopod but with the opercle cap, okay, covering the tip. So actually, why do we need to set this setup? Okay, so this part is quite difficult, so I show you the answer first. The feature of the setup 3 intact coleopod with uppercut cap on the tip. Okay, so actually it would like to show that the failure to produce the phototropic response in setup 2 is not due to the effect of damage when the tip is removed. So remember that the whole experiment, okay, done by Darwin, actually there are two conclusions. One conclusion is about the tip is necessary for growth, and the other conclusion is that the tip is sensitive to the unilateral light. Okay, so somehow, okay, it refers to part A as well. So some people, they will challenge you, the tip is not that necessary, or the tip is not that sensitive to the unilateral light. Okay, because they may claim that for setup 2, why it doesn't show any phototropic response, because when you remove the tip, you also damage the region of elongation, something like this. Okay, you may even kill the plants already. Okay, so there is no result at all. So that's why we have set up 3, okay, to cover the tip, but it is an intact coleopard. Okay, so without the tip, we know that it keeps growing, but without bending. So at least the tip, okay, there is some strange factor, okay, for the tip. So for the part C, okay, this is the experiment done by Jensen. So he would like to study the nature of the signal transmission involved in the tropism. So that means that the auxin, okay, will be found in this part. So just like the Darwin experiment, we have part A and part B, but the focus will be part B, C, D. Okay, so you can check from the book or any other exercise that for setup B, actually there should be a anchor block, okay, above the coleopard. But the point is that it doesn't matter, okay, because for the setup B, even we put the anchor block, okay, on the top of the coleopard, the body, okay, the anchor block, it doesn't contain auxin. Okay, so for this part, okay, in this experiment for setup B, no anchor block is put on the top, is also okay. So for part C, okay, for part C, we would like to draw conclusion, okay, from Jensen's experiment, from comparing A, B, C, D. Okay, so actually which part, okay, of the coleopard produce a substance which is chemical in nature and can diffuse through the agar block or the mica block, okay, to reach the lower part of the coleopard. And the substance, okay, it will need to something and something at the lower part of the coleopard. Okay, so remember the four steps, okay, of answering the question of tropism. Okay, so that means the growth and bending, okay, at the lower part of the coleopard. And for part D, so it's talking about the nature of science. So probably in this table, all of the statements, okay, they are nature of science. But the point is that all of them can be founded in the Darwin and Jensen's experiment. Okay, so for the first part, okay, doing science requires creativity and imagination. Both Darwin and Jensen used innovation and imagination to design their experiments. So the point is that both of them, they would like to study the phototropic response, okay, of the plants. So how can they achieve their goal, okay? Or maybe, for example, Darwin removed the tip, okay, to examine the importance of the tip, okay, to the plants, and then for the intact coleopard, okay, it covers the tip and covers the body to examine that which part, the tip or the lower part of the coleopard, is sensitive to the unilateral light. Okay, so it takes some imagination or creativity to set up the experiment and also do some prediction. Okay, And for the second one, science is socially and culturally embedded. And actually, it is talking about that the science is highly related to the society, the culture, the economy, and also the politics, something like this. So the example will be like this. During the World War I or World War II, most likely science, okay? Science, it makes contribution to the weapon, okay? They invent anything for the war, okay? Aeroplane, the tank, something like this. But after the war, okay, actually we need to develop our economics, okay? So that's why we need to develop different machines for the industry, okay, to make new things. And also for the power plant, or the power stations, apart from burning the charcoal, okay, to generate the electricity, okay, later on, the scientists, they develop the nuclear power, okay, nuclear energy to produce electricity. And after that, because in the society, many people, they start complaining about the risk of using nuclear power. So that's why science move a step forward, okay, to develop the renewable energy, or the solar energy, wind energy, something like this, to produce the electricity. So that's also a way to show that our science is highly related to the society, culture, something like this. And also, science is based on the evidence, okay? So we know that, okay, before we do the experiment, we do the observation, ask question, do the hypothesis, something like this. And after the experiment, we need to observe the result, okay, and check that whether the result is supporting our hypothesis or not, okay? So the scientific knowledge, okay, or the conclusion, okay, they cannot be drawn or constructed by someone just say that, oh, I think it must be correct, so it is correct, okay? We cannot do so, okay? We need to do the summary analyze, okay, based on the evidence. And also, science knowledge is tentative and dynamic, okay? So for the tentative, not certain. For the dynamic, that means it keeps changing, okay? So the concept is that today, okay, or a certain experiment is done, and then a certain conclusion is being drawn, okay, and actually it's very convincing, okay, for people, okay. But maybe tomorrow or the day after tomorrow, a new scientist he did a new experiment and draw a new result, okay, and he finds that the result, okay, is more convincing than before, okay? So probably we may adopt a new hypothesis, a new conclusion, okay? So that means the science knowledge is tentative and keeps changing, dynamic, okay? So in this experiment, okay, done by Darwin and done by Jensen, okay? So which of the following nature of science, okay, can be related to the experiment, okay? So actually you can see that the science is based on evidence, and also science knowledge is tentative and dynamic, can be related to the experiment, okay, done by Darwin and Jensen. And what is the reason? Okay, you need to write down the reason as well, okay? So I give you to do the matching, okay? I give you the answer already, but I want you to put them in correct order, okay? Do the matching. So for the science is based on evidence, okay, and science knowledge is tentative and dynamic, which one matches which one, okay? So for example, this one, both Darwin and Jensen developed the understanding about phototropism in plants based on the result from the experiment. So it should refer to the science is based on the evidence, or science knowledge is tentative and dynamic. And for the second one is that Darwin's work only provides some understanding about phototropism, and Jensen's result have developed further science knowledge. So that means the work, okay, of the past scientists, okay, it provide a foundation for the scientists in the future to develop more scientific knowledge. Okay, so this part, okay, I give you, and for the matching part, you do it for me. Okay, so that's for the briefing session for the chapter 15 assignment. So I hope that it can help you to do so. And any question, please leave your message in the message box. Okay, bye bye.